So since I ran out of time in that last video, I'm going to go ahead and do 13, and then I will do number 17. All right, so 13, in this case, we do have factoring that we need to do. So we start with our numerator and look at, does it have a GCF and, A times C and all that crazy business. So when we factor this, we get x minus 4, times x plus 2. And then in the denominator, we also have x plus 2 down here, and there's no factoring that we can do with it. And so what we do from here is we cancel out our x plus 2's, and that will leave us with x minus 4 over 1, which is just x minus 4. All right, so start with your zeros. Zeros meaning taking your numerator and setting it equal to 0. And solving. So you end up with x equals 4 because you add 4 to both sides of your equation. So we get 4, 0. Then what we look for is our y-intercept. And our y-intercept we get by plugging 0 into our equation. So we take our y equals, we put in 0 for x and subtract 4. So we end up with y equals a negative 4. And so that would be 0, negative 4 for our y-intercept. Our vertical asymptote, so we take our denominator and set it equal to 0. So for vertical asymptote, our denominator is 1, and 1 does not equal 0. That doesn't make any sense, so there isn't one. Horizontal asymptote has to do with our degrees and numerator and our denominator. And so our degree of our numerator is equal to 1. Remember, that's your exponent on the variable, okay? And then our degree in our denominator, that's not supposed to be an m. Our denominator is equal to 0 because there is no variable in our denominator at all. So what we have then is high over low, and so what that would mean then is that there is no horizontal asymptote, so none here. Now you'll notice that we did cancel out a factor, which means we will have a point discontinuity. So the factor that we canceled out was x plus 2, and when we solve that we get a negative 2. So our point discontinuity is going to happen at x equals negative 2. So we need to graph x minus 4. This is just a line, and so we need to go to our y-intercept of a negative 4, which is here, and we know that our 0 is going to happen right here, right? But we have to know this whole. Where is it going to happen? So it's at x equals negative 2, but what y value will we get? Well, our slope, so here's the line, x minus 4. The slope is 1, which we do 1 over 1. And then our y-intercept is a negative 4. So this is a 1 over a 1. It doesn't really look like that, but it is, I promise. All right, so we need to go down 1 and over 1, and at this point right here, we are at a negative 1 x value. And when we get to negative 2, we're going to have a hole. So I'm going to go down 1 and over 1 again, and we're at x equals negative 2. There's the hole. So now I'm going to attempt to connect this as well as I can. This is really hard to do. All right, there we go. So the hole happens at the point negative 2, negative 6. And the reason that we look for that is because we need that for our range. So negative 2 is going to be the x value, that part of our domain, and then this negative 6 will be the y value part, or the range part. So we have x such that x does not equal negative 2 because that's where our hole is, and then negative infinity to negative 2 union negative 2 to infinity. And then the range, we're going to write out y this time because that's what it's used in the original problem, such that y does not equal, and that's where we use our negative 6 and close it up. And then that would be negative infinity to negative 6 union negative 6 to infinity. All right, and then our last problem here For number 17 is solving, and so to solve our equations, we have to get a common denominator. So what I'm going to do then is factor, right? So I'm going to start with 6 over a minus 7. There's nothing we can do, so I'm going to put parentheses around that to show there's nothing we can do to that. Minus 1 over a, again, nothing we can do here, equals a minus 49 over, and we start with our GCF, so a can come out of both of them, leaving us with a minus 7. And so what do you notice is our least common multiple? What's going to be our denominator? And you'll notice that if we take a and a minus 7, that this one only needs an a, this one needs an a minus 7, and this one doesn't need anything at all because it has both pieces already. So we can build up. So we'll take 6 over a minus 7, and we're going to multiply by a over a. And then what we will do is subtract 1 over a and multiply by the piece it needs, which is a minus 7 over a minus 7. And then set that equal to a minus 49 over a times a minus 7. Okay, so now from here, multiply your numerators to get 6a, and then our denominator is a times a minus 7, minus the 1 we don't really need to write, but if it makes you feel better, we can put it up front just to remind you it's there, and then a times a minus 7 equals a minus 49 over a times a minus 7. So now that our denominators match, we get to ignore them because they're already equal, so we want to know what's going to make the numerators equal. So I am going to ignore this 1 now because there's no point, we don't need it, and write the equation 6a minus a minus 7 equals a minus 49. And then from here, I'm going to distribute the negative through, so 6a minus a plus 7 equals a minus 49. Combine your like terms to get 5a plus 7 equals a minus 49. I'm going to subtract a to move all variables to one side of the equation. And then I will subtract 7 to move all of the numbers to the other side of our equation. So this became a 0, this becomes a 0 here, so we get 4a equals negative 56. And then we divide by 4 to get a equals a negative 14. All right, so remember that you do need to check your answer, so always check. And so what I do is I write this and then I just put a check mark to tell myself that I did it, and then an X to say that I did it and it didn't work. And so I'm going to take that negative 14 and I'm going to plug it in, but I'm going to do this in the calculator because we don't really need to, put this in by hand. We can type it in exactly the way you see it. So come back to your original problem and type it in. So let me just show you how that would be done. So we're going to do alpha y equals to bring up the fraction, push enter, and 6 over, and remember our answer was a negative 14, so in parentheses I'm going to put a negative 14 and then minus 7, so that's the first part, and then minus, and we have 1 over a, so alpha y equals enter 1 over, and this would be a negative 14, close the parentheses, and there's the left side of the equation, comes out to a negative 3 over 14. On the other side of the equation, we had a negative 14 minus 49 over, and we had negative 14 squared, so that was a squared, minus 7 times a, which is a negative 14. And there we go. Uh-oh, what did I do? Oh, dang it. Okay, sorry, let me do this again. Second, enter. So negative 7, I think maybe I put, maybe I put minus there. All right, that one's good. Sometimes you have to be really careful and make sure that you use negative signs when you're supposed to. I think maybe it was the 14 down here that I did. That was supposed to be a negative. There we go, instead of a minus. All right, try that again. Okay, so we got negative 3 over 14, and I'm going to go ahead and pull up that first one that I typed in, and which was the left side of our equation, this one here, and we got a negative 3 over 14. So since it was equal, this is in fact a solution. So I'm going to go ahead and scroll down here. I checked it, it worked. So I'm going to do this to remind myself that, yep, we're good, and then come over here and box in a equals negative 14 as our solution to this problem.